Hi guys, I hope you had a good week. So what we're going to now do is we did areas last week, now we're going to do volumes, okay? So this week I'm going to show you how to find the volume of prisms and I'm going to show you how to find the volumes of pyramids. So let's start with prisms first, okay? So what are prisms? That's the first thing I'm going to ask you. What are prisms? Well, prisms are solids, all right? They're solids where there's a cross-sectional area. Well, what do I mean by that? So now, imagine this, look at this solid here. Imagine this solid is a piece of bread. Okay, so now, I will tell you now that this solid is a regular prism. And the reason why it's a regular prism is that if I get my knife and I cut every single piece like this, horizontally, what is it going to look like? It's going to look like this area, isn't it? So let's say if I cut it here, and I look at the piece of bread, well, this area and this area will look exactly the same, right? Now, what happens if I cut it this way? Well, if I slice it this way, every piece of bread will be different, okay? So, however, for a solid to be called a regular solid or a regular prism, you only have to slice it in one direction. Okay, and if you slice it in one direction, any direction, but if there's one direction where the areas look exactly the same, then it's called a regular solid. Okay, so now, if you're asked ever to find the volume of a regular solid, I want you to remember this formula, that the volume of a regular solid is cross-sectional area times height. So that means that to find the volume of regular solids, all you have to do is to find the cross-sectional area and then find its height and times the two together. So basically what I'm going to say to you is this, that when I teach you volume of a prism, if you know how to do area, you know how to do volume. Because to find volume, you get the area and you times by the height. Okay, so let's have a look at some examples, okay? Now, I want you to find the volume of the following solids, okay? So in the first one, we are given this solid, okay? And what happens here is a lot of people, they get caught up on, oh my God, what's the name? What's the name? Look, can I tell you this? I don't really care what the name is. All I want you to say to me is this a regular solid? Is it? Well, as I said, think of it as a piece of cheese to go with this piece of bread. Okay, so now this cheese, if I cut it like this, what do I get? Well, I get, if I cut it here, slice it down, I get a rectangle. And if I cut it here, I also get another rectangle. But the rectangles, this one's a small one, this one's a big one. So that means the slices don't have the same area. Well, let's try it again. Let's cut it another way. If I get this piece of cheese and I cut it like this. So if I cut it like this, what do I get? So let's cut it. Let's cut it. I'll cut it for you. Okay, let's cut it. There, and there, and there. If I cut this like this slice, what do I get? Well, I get a triangle. So every single time I cut it, every piece will be a triangle. So what does that mean? It means that this is a regular solid, okay? Okay, then, so now you've determined that it's a regular solid. The question is, well, what's the cross-sectional area? The cross-sectional area is the area that the area of the slice, okay? So if I cut it like this, what's the area of each of the slices? Well, it's the area of this triangle, or it's the area of this triangle here. Because this triangle and this triangle are the same triangle, right? Okay, so now inside your head you go, okay, now I know it's a regular solid. Well, the volume, to find the volume, I just get the cross-section area, I times it by the height. And what's the cross-section area? Well, the cross-sectional area is the area of a triangle. So how do I find the area of a triangle? To find the area of a triangle, I just get the half, I get the base, which is 10, and I times it by the height, which is equal to 5. So that's going to be equal to half of 10 is 5. 5 times 5 is 25. So now I know the triangle, the cross-sectional area. Once you know the cross-sectional area, well, you times it by the height. But in this case, the piece of cheese is lying down It's not standing up. So the height, you can replace it with the length, okay? So the length, so the volume is equal to, the cross-sectional area is 25, and you times by the height, which is the same as saying the length, which is 10. So it's 250. Okay, so units cubed, and that's its volume. Let's move on to the next one. Well, in the next one, what I have is I've got this object. Now, a lot of you guys are screaming at home. You're thinking, oh, it's a cone. No, please, don't call it a cone. A cylinder. Please, don't worry that it's a cylinder. Don't call it a cylinder. What do I want you to call it? I want you to call it a regular solid. Why would you call that a regular solid? So again, let's think of this as a salami to go with our piece of bread and our cheese. So think of this as a salami, okay? Now, if I cut this salami like this, if I slice it, right, what do I get? Well, each piece is going to be a circle, isn't it? So since each piece looks exactly the same, it's going to be this circle, then it's called a regular solid. So if you know that it's a regular solid, even I don't care that it's a cone, it's a cylinder. It's a regular solid. So if you know it's a regular solid, you will say to me straight away, hey, if I want to find the volume, the formula is cross-sectional times the height, okay? Or remember, if it's lying sideways, it's called the length. In this case, it's lying sideways, so I'll call it the length. So the first question is, what's the cross-section area? What's the area of each of the pieces that you chop up? Well, it's a circle, and we know the area of a circle is pi r squared. So we write pi r squared, which is equal to, well, what's the radius? You can clearly see from this picture that the radius is equal to 6. So it's pi times 6 squared, which is 36 pi, right? So that's the hard bit. The hard bit is actually the area. Okay, so now we found the cross-section area. Let's go and find the volume. The volume is, you take the cross-section area, 36 pi, and then you times it by the length. Do we know the length? Yeah, there's the length. The length is 20. So you times by 20, and that's equal to 2 times 36 is 72, add a 0, and that's pi units cubed. I don't have a calculator with me, but if you do, you can grab that and sub pi as 3.14, okay, to get the exact answer. I mean, the answer in decimals. Okay, so now that's that one. So I hope what you've learned here is that, note, I didn't call this a triangular prism. Note, I didn't call this a cylinder, because I really don't care what the shape is called. I just want to know whether the solid is a prism or it's not a prism. If it's a prism, then the volume is the cross-section area times by the height, or the cross-sectional area times by the length. Okay, now let's look at this one. Okay, so we look at number 3, and in number 3 we say to ourselves, well, how do I find the volume of this solid? Is it a what? Is it a regular solid? Yeah? Okay, now let me ask you this. Is it? It is, isn't it? Because each time I cut this solid like this, I get this surface, don't I? Yeah? And so this surface here is called the cross-sectional area. Okay, so now after we understand that it's a regular solid and we understand what the cross-sectional area is, let's go and find the volume. Well, let's write the formula. Volume equals cross-sectional area times the height or the length, okay? So the question is now, what's the cross-section area? Well, have a look at this shape. Have a look at this shape. What is this shape? Well, it's a shape where this is 90, this is 90, so that means that these two lines are parallel. So it's a four-sided shape with two parallel sides. Okay, so what's that called? That's called a trapezium. So how do we find the area of a trapezium? The formula is half. You times by the height, you times by a plus b, where a and b are the lengths of the two parallel sides. So that's equal to half times by the height. And what's the height? The distance between these two parallel sides. So if you look at this, that's the parallel sides. All right, so it's a half times the height, which is 10, because that's the distance between the two parallel sides, times you add the two parallel sides together. So it's 6 plus 12 is 18, yeah? Okay, so you got 6 plus 12. Okay, let's work out what that is. So that's going to be 6 plus 12 is 18. You divide by 2 is 9. 9 times 10 is 90. So once again, that's the hard bit. finding the cross-sectional area. Now, to find the volume, all we do is we get the cross-sectional area, which is 90, and we times it by, what's the length? The length here, we can clearly see it's 4. And that's 360 units cubed. All right, guys. Now let's have a look at question number 4. This one's a bit harder. Okay. So if you look at this question here, what we have is we've got something that looks like a house, doesn't it? And it's got a hole. Okay. And it says that this is 20, this is 10, this is 20, this is 10. Okay. And there's a hole there with radius 5, and it goes right through. Okay. The aim of this question is to go and find the solid. Okay, so what would you normally do? You're probably thinking, what I'm going to do is I'm going to find the area of this, what is it called? If this is 20 and this is 20, so this would be 20. And since this is 20, 20, they're equal, so it's going to be a square. So you're going to say, I'm going to get this square prism, and then I'm going to add it to the roof, which is a triangular prism, and then I'm going to minus this cylinder. No, none of that rubbish here. No. Whenever you see a solid and they're asking you, what is the volume of this? What you need to do is this. You need to say to yourself, is it a regular solid? So think of it as a bread. Now, chop it up in any direction you want. Try and see if there's one direction where you chop it up, the pieces all look the same. And in this case, there is. If I grab my knife and I chop it like that, every single piece will look like this. Isn't it? Okay, every single piece of bread will look like this if I chop it like that. So this is called the what? The cross-sectional area. Now let me just shade it for you so you can see. Now what's the distance from here? The distance from here is 20, so that's 20. The distance from here to here is this distance here, that's 20. Okay, and the distance from here to here is 10, so that's going to be 10. And so we have that, don't we? And this is 5. Okay, so we've got that dimension, right? So now your aim here is to find the volume. So how do you find the volume? Volume equals cross-sectional area times height here. Okay, and so now, to find the volume, we need the cross-sectional area and we need the height. Well, or the length, okay? So the height can be called the length as well, right? So now, how do you find the cross-sectional area? So what is it? Well, that's the cross-sectional area here. Well, it consists of a square and consists of a triangle with a circle taken out of it. So the cross-sectional area is equal to the area of the square, so it's 20 times 20, plus the area of the triangle. So how do you find the area of the triangle again? It's a half times the base, which is 20, times the height, which is 10. And then you minus the circle. There's your circle there. You minus, and what's the area of the circle? Do you remember from last week? It's pi times r squared, and r here is 5 squared. Okay, so now let's do the calculation. 220 is 400, plus half of 20 is 10, 10 times 10 is 100, minus 5 squared is 25, pi equals 500 minus 25 pi. All right, so now I've got the cross-sectional area done. All right, so now let's go and find the volume. Well, the volume is equal to the cross-sectional area, and then you times it by the length or the height. This one's lying flat down, so we times by the length, which is 10, and then you use your calculator, work that out, and that'll be units cubed. Okay, so now very simple. So the first part on this question in this lesson I want to teach you is how to find the volume of solids. And the solids you're going to get in school will be what we call prisms, okay? Regular prisms, okay? So regular solids, which are called prisms, okay? So now, I don't care what the name is. I don't care if it's a triangular prism or a cylinder or whatever, I don't care. As long as you see that it's a regular solid, all you do is you find the cross-sectional area and times by the length or the height. So basically, volume questions, the most important bit is to find the cross-section area. So that means that volume questions are basically area questions. Okay, so now I'll get you to copy these questions down, and then in the next video we're going to do much harder questions. Okay.